What's up, everybody? Welcome back. Today we are working on our map. So this is our map. It's a map of Vancouver, and today's topic is trying to do some sort of like path planning through it. So where we're at right now is we've kind of yoinked a bunch of data from OpenStreetMaps, and here we can kind of like look at it and inspect it in some way. So we've kind of got this like little cursor on the center of the screen, and he can jump around and like look at what each of these little lines represents. And so if we want to see like, okay, like how would we paint a path through the city? Well, we would like look at some of these lines and we'd say, okay, so this is a highway. Well, it says highway. Highway's kind of like any road. And we can like look like traits about them, right? So this is like a walkway. This is like a residential street. This is down here probably is like a big street. Maybe down here. Yeah, so this is like a secondary highway, which is like a big street, but not like the biggest street. And so the idea is we should be able to like kind of build a graph of all of this road data and do some sort of path traversal through it. So that's the plan for the day. I think the way we want to go about this is we're going to start by kind of like limiting the amount of data in here. So initially we pulled all of this data from OpenStreetMaps and we rendered it all because we didn't know what it was. And we found out that there's a lot of stuff here we don't give a shit about, right? So like building. We don't care about buildings, we only care about roads. We will probably want to fix the fact that this map is like super fucking squished vertically, right? So we are kind of mapping everything as if the degrees in latitude and longitude are equally spaced, which is just not true, right? If you look at like a globe, come on, there we go, right? If we have like globe and we have like longitude lines and latitude lines, as you get closer to up, the distance between longitude gets smaller. So we need to fix that for sure. But I think that that's just like going to be a simple like quick little math thing on the input data. I think it's probably just like a simple formula to map between them. We need to be able to navigate from our we need to be able to like start and end our trip at a position. So right now we're finding like the closest street to us. So if I turn on this debug view, we can kind of see like what we're mapping. This is like close to what we want. But we actually want the closest node, not the closest street, probably, to kind of like start somewhere. And then once we have where we are on the graph, we can start looking at visualizing, or sorry, we can like start making a path planner. So we'll pull like a star and kind of just start there. I think a star is a good initial guess. We are probably going to need to adapt a star as we go, but for now it's a good place to start. And I think that if we get there, I'll be really happy with the progress for the day, and if we don't get there, I'll be really unhappy with the progress for the day. So we'll see how far we get. We'll see if we get a little happy face or a sad face at the end of the stream, but that's the plan. So let's start with just limiting the map to only roads. This should be pretty easy. So I was looking up like what are these tags, and so just kind of skimming around here, you can kind of like see something on the right, and we can kind of see that like roads typically have this like highway thing. So I was looking up like Open Street Map road, and nope, highway, sorry. And they do talk about here where highway is the main key identified used for identifying any kind of road, street, or path. So all we should have to do is we take this like blob of XML data. Let's see it. Let's see if we can find it. This shit. We take this blob of data and we basically convert it into like a binary format that we are happy with by basically walking all of the nodes and all of the ways, where ways are like basically edges in a graph and nodes are nodes in a graph. And so we should be able to basically say that we'll look at each way that we're looking at, and we'll look for a tag with the key highway, and if we don't see it, we'll just drop it. We just like won't serialize it as part of our output data, and then we should just kind of get stripped down to what we want. So we have this thing called make site. It makes the site, part of make site's job is to run the XML parser, and he says basically, when I end an element, oh shit. Okay, so what he does is when he starts, he has like a file writer object, and he's just like ripping shit into him. So like every time he sees like a node reference, he like just writes that stuff out. If we're going to be dropping ways that are not part like that do not have a specific key, then we're gonna have to like kind of buffer this stuff. So probably what we're going to want to do here is we're going to want to say like this way nodes is going to be like an array list of U32s. Yeah, I think. And here we already keep track of the tags, so we can just rip them at the end. And then what we'll do is instead of like writing stuff as we go, we'll kind of just take. So here we're going to say that instead of writing it to the output, we'll say that the user data this way nodes append the node index. Okay, that's easy. And then catch unreachable. Fuck it. Fuck it. Then also when we see a way, we put a sentinel value in our binary data that kind of doubles both as a way for OpenGL when we draw the map to know where line segments start and end, as well as for us on the CPU side to know that this is like a new item. So here we just kind of are gonna take this stuff and just do this on the way out. So on the way out, we will still write our sentinel value. Then we'll write each node ID. So we're gonna say for user data this way nodes items, we get a node index and we write that thing out. And then we append the like tags associated with that road into our like JSON metadata that goes along with it. And so now all we have to do is we just have to say like if let's see, user data tags is this, what is this thing? This is an array list of tags. So we have to search it manually. So for user data this way tags, items, you know, really we probably could just like write down. Yeah, we probably should just write down. As we're going, we should just write down if we found highway. That's probably better. So then we can just say down here, user data found, if we found a highway, we do this. Otherwise, we ignore it. How are you liking Zig? I find it very fun to write. Very, very like pleasing to write. I don't really have like a very strong rationale as to why. I just know that like I started writing it and then I kept writing it. Here, when we enter a way, we also have to set the found highway to false. And then here, we need to say that if we see a key that is equal to highway, we say found highway is equal to true. Apologies that I didn't go into more detail on the Zig thing. It's just I'm not really super confident in my ability to, you know, get through everything today. So I would prefer to be a little bit more terse on my responses and just kind of bang shit out. So apologies. So this is a array list of node IDs, so U32. Initialize this with an allocator. And then we have to make sure also that we clear out that list every time we enter a new way. So here we need to say this way nodes. Oh no. Yeah, we do. Clear. Clear retaining capacity is probably more reasonable, right? Because probably we're going to like allocate, we're gonna see approximately the same number of nodes each time, and even if we don't, it's like the overhead of clearing and then reallocating every time is silly. We can kind of just say, if we overallocate here a little, it's not a big deal. Not a big deal. Let's initially test this with the shittier version of the data, as in the data that is, there's much less of it. I took like a small snippet of like a piece of downtown Vancouver versus like the whole city. And so now we can at least see, yeah, I'm pretty sure that these are all roads. Highway, the node searching here with such a small area is kind of stupid because we can like bucket basically the ends of the lines into into like certain areas of the grid. And so like if we're not close to where, if we're not in the same bucket that the edge of the line is in, it doesn't work. But you know, this is to be improved in the future. It's like good enough when we run it on the full data, which we will do here in a second. Okay, so I'm pretty sure that that's working. So we can run this on what is it, 534. This is the big boy. I don't know why he's rebuilding every time. There seems to be something wrong with like the caching. I might have to like clear the cache and reset it, but I'll give him a second. He's gonna think this step is fairly expensive, but I'm hoping not much more expensive than it used to be. There's a memory leak here, and before anybody calls me out for it, I know I just don't care, because like if it's like you leak data at the end of your run, it's like I don't really, who cares? Oh, that's a lot of leakies though, so maybe I actually do care. That is a lot of leakies, but maybe it's fine. Okay, so we have lost all of our buildings, which is good for us. That's really good. So we can say this, and I'm also kind of curious, how much smaller did the output get? Not that much smaller, to be honest. This kind of like halved, or maybe like 3/5. This is about the same size. Oh, that's fine. It's fine. Doesn't really matter. Okay. So I wanted to fix kind of the like latitude longitude mapping. So I think there's just a lat long 2 meters. Wikipedia. Is it this? Was what I'm looking for? No, maybe it was this one. Here we go. Here we go. This is what I'm looking for. Length of a degree. So on the WGS 84 spheroid, the length in meters of a degree at latitude, this. So the length in meters of a degree of latitude at this latitude is this. Got it. Oh, that is the number of meters you would have to travel along a north-south line. Oh, yeah. So, okay. And similarly, the length in meters of a degree of longitude can be calculated at this. Okay. Sure. So the question is how do we want to store this data? Right? So, probably we don't want to work in degrees ever. Probably, I think like the vast majority, like for the map rendering, we'll be wanting to work in like unwrapped space, because like it's not like we're trying to render like the whole globe where we actually need to keep that like the wrapping into account. We're only rendering like a very small slice of the world. So kind of just like unconditionally unwrapping is probably fine. And so I almost wonder if it makes sense to just like in place convert the data before we upload it to the GPU. So we can kind of just make everything relative to like the center. We could even go as far as to like convert the floating point data to U32s, because like to avoid like floating point imprecision as we move farther from whatever our origin point is. But in reality, that floating point imprecision probably won't matter. So I think that's reasonable. Now let me think about, do we want the data to like be just in this unit? Like on the wire? Maybe. But maybe we want the freedom to kind of adjust this stuff as we go. And I suspect that we can just like that doing this conversion client side is not going to be that expensive. So I'm just going to do it there, even though I'm not really sure that that's the right place, just because I want to get something so that we can keep moving. So yeah. Thinking. Yeah, fuck it. So here, maybe on app init, we're gonna do something like basically rip through this stuff. So we're gonna say that like maybe the point data is like alternating latitude, longitude, or maybe it's alternating longitude, latitude. It's probably alternating longitude, latitude, because OpenGL wants it in XY. So we're gonna say like for 0 to point data len over 2, we have I. The lon is going to be point data I times 2, and the lat is going to be this plus 1. And we're going to set everything maybe just relative to the top left corner. So we have like the min lat and the min lon. We'll just set these to 0. So, okay, so this is 1113. Oh, somebody also said it's reliable data you want to convert from this format to that format. I don't really know what those are. EPSG 4632. Coordinate system. Yeah, I mean, I don't think I care this much. This looks like just 4632 is the one you have. Yeah, I think I don't. Honestly, I was like almost gonna do this. So I'm not really gonna be too worried. I also thought that I saw that like yeah, I don't know. It doesn't. I'm not worried about it. I'm not worried about it. Okay, so we'll just copy paste this formula. So this is this minus. I'm not sure if they're using like funny minus symbols, so I have to be a little careful here. This is cosine 2 times phi plus 1.175 times, these are also times here. This is cos 4 phi, like this, minus this. Cos times 6 phi. Okay, this is the latitude. So this is going to be like the latitude data is going to equal this, where phi is the existing latitude. So we do this, we do this, we do this. And the ln yeah, and then we subtract. What does this give us? This gives us the change in 1 degree in latitude. So we need to multiply this whole thing by the minimum latitude, by the difference. So times lat. You know what we can do actually? We don't have to be like super duper precise. We can actually compute these up front, where we can say like lat step and ln step is equal to this stuff. And then we can say that we're just going to use the center lat. We'll use min lat just so I don't have to do the calculation. Fine. Center lat is metadata min lat plus metadata max lat over 2. And the center ln is the same. Oops. Like this. Okay, and then here we can just use center lat. Center lat. What did I just do wrong here? Center lat, center lat, center lat, and then here we can use, I guess we need to copy the new formula, huh? Okay, delete word. This is this times cosine of, this is just phi, so center ln minus 93.5 times cosine of, I assume this is 3 phi? Yeah. So this is 3 times center ln plus 118 times cosine 5 phi. There we go. Good enough. Good enough for me. Doesn't have to be perfect. It just has to be not uber shit. Okay, so now we can say that the lat is the lat step times center, I guess lat minus metadata min lat, and then ln is the same. Okay. This cosine needs a little at sign, a little at sign. A little at sign here as well for compiler built-ins. And then we need to make sure that like the view state is reasonable here. So we need to make sure that, so we need to see basically the width of this thing is going to be lat step times this. Whoever just typed today in chat, you can read the top right. You can read the top right. Okay, so this is the width. Sorry, this is the height, and this is the width. So width is longitude, longitude, longitude. And now, so the zoom level is going to be whatever makes this 2.0. So 2.0 over width. And the latitude and longitude is just going to be width over 2.0 and height over 2.0. Is going to be the screen center. And that should just kind of make everything just work. Maybe? I'm trying to think if there's anything else that we need to worry about. But I think, no, I think everything else just kind of gets the right data for free. Cannot assign a constant? But why can't I assign to the dereference of the constant? Do I really have to write var here? No, it says never mutated. That's confusing. Yeah, local variables never mutated. Oh, no? I don't get it. I'm actually really lost here. That's a weird error. This is at line 101. Point data is const. Oh, yeah, that'll do it. Good eye, good eye. And I guess it doesn't have to be. So we'll just fix that. We'll say, fuck you. We can do what we want. So that means an index zig. Here that's fine. But on the local thing that we made just pre-stream today, we need to just fix a const UA here as well. We'll just say, fuck it, it's mutable. I don't give a shit. And we'll just have to be careful not to mmap it later, but it's probably fine. So zig build, optimize, release, save. And then are we running the web server? We are, so we should just be able to like refresh this actually. Unreachable executed? Maybe because unreachable executed. Surprising. Surprising, surprising, surprising. And this is probably from the change we just made. So if we go back into what is it? App? Like just double checking here that if we comment out all of this stuff, fuck. And then fuck width is equal to I guess we need to define these over 2. Height is this. I'm assuming that this is fine. Assuming, but who fucking knows? Refresh. Yeah, I mean, that's fine to the extent that, well, it still hits an unreachable there, actually, but it does render the map first. So this is hitting unreachable because I set the center to just be... I actually don't know why this is hitting unreachable. I don't know why. This is at on mouse move. Oh, yeah, sure. So we're probably just out of bounds of the array or something. Our initial state is out of bounds. But I don't know if that means like that means that we got past initialization. So here on initialization we're failing somewhere. And ooh, we can actually use our new native version of the app to debug this, because we can see if it also crashes in the native version, and we can run smap on the same data. And he does. Oh, that's so nice. Oh, what a big win. Holy. That's actually so sick. Oops, I need to native version. So this is at so we push because the bucketing of ways is using assumed latitude and longitude. So we need to update this way bucket thing to initialize based off of like width and height. When did you add the native version? Like in happy hour today, because I didn't really think it was worth like its own stream, but it's just like it doesn't actually do anything. The native version is just he just instantiates the app and then calls a few functions on him. It's mostly for like linting. Okay, so now instead of this, we take in width and height, and I guess probably the way buckets initializer also needs to know that he takes in width and height. And here it's that where whoever used the metadata before is going to use probably width and height. And I don't know what they're going to do with them though. So somebody in here must be using metadata, and it's probably in like the latitude longitude to bucket conversion. So these are actually not going to take in latitude and longitude anymore. They're going to take in like x and y positions, but we'll pretend they're latitude and longitude because I don't want to fix it right now. So here is just going to be, we have lat and long dis now, or just width and height. The offsets are now just the values. So this is going to be lat over height and lon over width. I think that's the way the coordinates systems worked out. We'll find out in a second. Yeah, there. Okay, so that runs successfully, which is a good sign for us, which means that this probably will run successfully. Cache is disabled. It's spending a long time thinking, but I don't know if he's like not making progress or not. Looks like he's running. So it could just be that this parsing is actually a lot more expensive than I thought it was going to be. That's annoying. Because it ran natively pretty quick. I wonder if the like WebAssembly like memory is way slower. We're also seeing index out of bounds here on mouse move. So can we on mouse move? It's annoying. Annoying. I wonder if we can. Okay, so the mouse tracker get movement. He's storing normalized position, which should be the view state center minus the movement x over the view state. So I think all of this should just work. It's possible that it's this. Let's just maybe log. Can we like std log debug x and y? And then here also log the mouse down. And then that should give us a bit of a clue about what's going on here. And it seems like this thing is just slow, so I'm gonna run and release safe. because that launch time was atrocious, which kind of indicates that we should probably be doing that like initial parsing on the data processing side, but fuck it for now. You know? One misses. Yeah, okay, that's not too bad. And so here we got a mouse movement on x 0.2, y 0, because we should be able to just go into our version of this thing, the local version, and just kind of do those same things. So we didn't see any mouse down log, which I believe we should have if we saw mouse down, but we didn't press the mouse down, so that actually makes sense. So we can just kind of take these numbers and shove them in here. And debug locally. The only problem with having to run and release is that it's much slower to compile. Much slower. And also hard to debug. So I wonder if maybe on the native side, it's not so slow that it's a problem. One Mississippi 2. So interesting. We're not actually crashing. We're not crashing using the same inputs. Same inputs on the native version. Interesting. That's also quite surprising to me. Are we running with like the same output map data JSON, and this is running coming from output? And all of this stuff is uncached. So interesting. Interesting. Can we maybe I guess we didn't run in release mode there, so it's possible that that's related, that like the errors are only happening in release. Dude, this is unbearable. This is unbearably slow. So I guess we should just move the conversion onto the pre-processing side. Oh, fine. Make site. Make site. And it's not trivial to do that though. It's not trivial. So this still is crashing on mouse move. And it's happening in a load. So just like a pointer load. I wonder if it's like possible that we're like running out of... Can we look at like the stack here? What value are we trying to load here? Does it say? Not really. How annoying. How annoying. Well, we know that it's on mode. We can start bisecting, I guess. It's just, it takes so long because it takes so fucking long to run. App zig on mouse move. So we know that it's not related to mouse down because the mouse isn't down. So it could be in here. I mean, it also seems unlikely to be in a function call unless the function call got inlined, but it shouldn't get inlined automatically. So we know that there's some pointer load that is failing, which kind of makes me think it's like something like this. So if the min way is less than the tag's length, then we look at the tag. Okay. If the min way is less than the ways len, there's no thing. It feels like this is like the only like raw pointer dereference, but I mean, who knows? I hate having to bisect, but fine. Binding, renderer. Ugh. How annoying. How annoying. Finding potential ways. We are generating calculator. Does it happen on the smaller map as well? Oh, that's a good point, because that would be a lot faster to debug. That is a good point. And I will look at that in a second. We will try that. We will try that. But first, let's just see. Running calc. And then here we'll say tags And this is rendering selected. I'm gonna give it one run like this, and then if this doesn't fix it, then we can look at the slower version. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5. Yeah, it's actually not that bad. So, tags. Yeah, that does make sense. So I don't really understand why. Because we do check that the metadata, it's within bounds. I guess this, even here, like, minway, am I fucking stupid? Calc minway value, if it's less than the way tag's length, then we jump into the way tag's length. I guess it's possible that there's like some sort of memory corruption on the tag itself. Yeah, what the fuck? So I'm assuming that if we do this, it's fine. I'm assuming. Yeah, very strange. Very strange. Is this like... I'm assuming that this is the problem. Like, it should crash if we do this. Where we don't actually try to push the tags to JavaScript, but we do index into the map. But it's just like, if we're indexing in, then there just must be memory corruption. 1, 2, 3, 4, 5. Oh, that's also fine. That's a lot more confusing. Unless it's just optimizing this out because we're not doing anything. Std debug log debug. Can we like see what the fuck this thing is? This is so stupid. I feel like we haven't changed anything that relevant here. I guess if maybe... Yeah, I guess some form of memory corruption could be causing this. Or if we didn't correctly ignore ways that aren't part of the... No, that does do it. And it's just like off rip. The first one fails. What the fuck? So this is going to be the calc minway value and the self metadata weight tags len. And can we maybe like print like a few of the weight tags? Like, what the fuck is going on? What's the underlying data structure? If it's resizing, the pointer might not be valid any longer. Everything is like working. I guess that's possible. I don't think so. I don't think anything should be doing any resizing like that. And I don't think there should be any like stash pointers like that, but it is possible. Yeah, I think that the way list is just corrupted. Because that's a really big number. There are definitely not that many tags. So what's going on there? In the metadata, we have way tags. Did I do something stupid like free the metadata? No, we don't free the metadata. We get the metadata in here. The metadata gets stashed here. And then we use it wherever the fuck we were just now. On mouse move. And so this is coming from metadata way tags for this way. I guess it's possible that there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 2 billion ways? No fucking way. There's no way that there's that many. So we could maybe, I guess we just log on initialization what we get here, and then we can at least know if we've like done some sort of like fucked up invalid memory access. So we can do like metadata dot way tags. I forget way tags. Yeah, so it's like right off rip here. So it's the top level one. Num way tags is a number. A number. Oh fuck. Oh fuck. Oh god, what have I done? Num way tags. Might need to dupe the tag strings, but I don't understand why I would, because I'm not freeing anything associated with them. And it's also like, it seems like the number of tags themselves is getting corrupted. Or it's like the number of ways that we have tags for seems to be getting corrupted. Which is odd. So here we have 142,000, which makes way more sense. And then, yeah, somewhere it gets corrupted. Let me think. So yeah, here we have 142,000. Then we like can print a few this time, but then we get down here and then we start printing like empty shit. Yeah, and here we're starting to print some fine. So there's like, we could be like, if the fact that this doesn't happen, we don't seem to get any problems on our native version. That's an indicator of something. I wonder if we Valgrind the native version, if that will like tell us that we're doing some sort of invalid memory access. But I would think no. It's possible that just like we are like there's some WebAssembly option where we're getting like limited by the runtime in some way, we just don't know it. Although I feel like nothing should really have changed is like the weird thing. Like all we've done is just adjust the coordinate system. So I don't really fully get why that's a problem. Oh. Okay. So there's something there. He's losing some debug info. So can we do optimize without optimizations? Is this still gonna be so slow that it's like unusable? We will see. Going from 150k to 4 billion is a little weird. It just feels like something is overwriting some memory that it's not supposed to. Right? And we can see like conditional jump depending on uninitialized value is like pretty sketch. Use of uninitialized value also pretty sketch. So I'm just kind of hoping that Valgrind will tell us where that came from if we wait. Oh! Fuck. I was hoping to get through this stuff faster because I wanted to do the actual A-star algorithm today, but it's possible that this investigation sidetracks us enough that we don't really get there. But in which case, you know, that wouldn't be the end of the world. Not the end of the world. Yeah, this is really fucking slow. I wonder if we can get like better debug symbols in the release version of this so that we can like run under Valgrind without like taking a fucking year. I guess also we could check now is a good time to check if it works on the smaller version. We might as well, because that should be way faster. Should be. So Valgrind. We do see one of the same issues, but not necessarily all of them. But and then does this still happen? There's a bug in this one where when we end up like outside of the bounds, there's like a known crash there. Oh, here we go. Wait, this felt like yeah. This is still hitting it. Good. That's really good. So now we just have to figure out which mouse moves he ran. Okay, wait, hold on. Valgrind. Let's just run Valgrind here and see if it tells us anything useful here. Okay, so we are seeing no corruption here. We're seeing msync start, okay. And then we're not seeing any of the invalid memory accesses here, which kind of sucks. But it might depend on like the memory movement, the movements that we're making. I am Rebellious. Thanks for the prime. Appreciate it. So okay. So we can kind of like look for the sequences that led to this corruption. Let's also like reduce the logs here. Because we kind of know now that we're just kind of looking for this number to get like kind of fucked up. Oi. It's okay though. It's part of the process, and we'll learn something as a result. You can filter in the DevTools. Oh, that's good to know. So 201. Everything says 201. Oh, interesting. It's actually harder. It's not reproducing now. Is it possible there's some sort of like stack corruption going on and that's resulting in problems? Oops, that's not the right crash. Not the right crash. No? What did we just change that made this happen versus not happen? Weird. Was it only in release mode, maybe? Could be only in release mode. Or it could be that we had to hit some, like, specific point. Zoom level? Yeah, I mean, I don't think that should matter, but it was worth checking. It could be that we were in release mode and I forgot. Could be. Oh yeah, it's totally fucked here. And we're just like, we're not necessarily okay. Let's add an assertion here. If self metadata way tags len is not equal to 201, unreachable. That should help us catch it like a little bit earlier. Because like I think that what's happening here is we are happening to not crash. And that is confusing. Let me double check that. Okay, now let's get rid of some of these other logs. This is kind of the only log I really want, is the way tags len. because I believe this is where the corruption is happening. So let's equal tag. And then let's just make sure that like if we deleted some of the logs that the thing still happens. Cool. Nice. Nice. And then this is very clearly was 201, no longer 201. Sick. And then do we reproduce the same thing now if we run in our thing? Zig out bin smap. Oh, smap with a output map data bin and map data output map data JSON. Ah, okay. So interesting. It might be related to where we go. Yeah. So here, okay, here's what we'll do. We're going to try to, you said I can filter in here. I could filter for the X, Y movements. Although I'm not logging on every mouse move. So here we should say stood log debug of X and Y. And maybe this is related. You're 2-step saying that there's a max memory field that maybe changes out text. I agree that there's a chance, but I also am not really convinced that we should be doing that much, I don't think that we should be changing the amount of memory that much during, like, runtime. Like, I think that we do a bunch of allocations on init, but not after. That's what I thought. I could be wrong. Okay, so here, let's just try doing this. It seems like this is, like, failing, like, right off the bat here. Oh, and actually, this mouse move... I could be wrong about the fact that this is related, like, where the mouse is moving, because it's not even with the mouse down. And I also don't understand why, like, I would think that, like, we've reduced our memory usage. I would think. Yeah, okay. I guess another option here is that on init, there's a possibility here that this is causing we've like indexed out of bounds in some way, although I don't understand why that would be. Is it possible that we've accidentally cast something away that we weren't supposed to? Okay, so let's just say we don't reassign latitude and longitude here. And our view state gets this width and height. Does this fix the problem? I don't think it should, but I obviously don't understand the problem because I don't think it should be happening. So, it's worth taking a try. It's worth trying. Unreachable executed? Surprising. Just somewhere completely different now. Which is fucking annoying. Fucking annoying. Floating point value out of bounds. This is maybe a clue. Maybe a clue. Oh, this shit again. This shit again. So the width I'm using lon and lat. This gets pushed into here. Okay. Oh! So it could actually be related to the... If we fucked up this way buckets thing, then that could be related. Because that could be writing into, like, who knows what memory. So he's mad because lat long to bucket. I'm not convinced here. height over y buckets, width over x buckets, height and width should be coming from the original latitude longitude data, which is being used here, so I don't really understand why this is a problem. But I guess we could just look a little closer. So let's see if this is happening in debug, because that will give us better error logs. Integer part of floating point. Okay, so we can just frame 7 p call f. Okay, so latitude and longitude are reasonable. Oh, I guess that would do it, huh? That would do it. That it is expecting latitude and longitude relative to the top left. Okay, here's what we'll do. Here is what we will do. Can we just disable the fucking way buckets? This is causing us problems. So if it's causing us problems, we just ignore it. We ignore the problems. We make them go away. So maybe we do way buckets is just gone. Get the fuck out of here. This is just gone. Prices for another time. It's more like we just need to bisect this thing somehow. So can we just kind of like do this, then all of the way bucket stuff, get that shit the fuck out of here. Boom, boom. Point lookup goes away. Width and height go away. And then way buckets get and then we can't do this calculation either. So all of this kind of has to go away. So this is kind of propagating kind of far. Can we do here? We just look at all ways. Maybe I'll just comment this out. Yup, sure. Then everything else can still compile. This has to go away. And then there was this one in DNA. Okay, maybe? Oops, address is already in use, so I can just refresh here. So we are still getting that unreachable. Interesting. Interesting. And this is on the same thing where I'm assuming maybe we log. We should just make sure. Bad, bad, bad. I want to be very, very confident that this is what we're seeing. Bad, bad, bad. Yeah. Okay, so it is still getting corrupted even without the way bucket stuff. And without the latitude longitude rewriting. Dude, we didn't change anything. Right? Am I fucking nuts? Okay. Can we just get like... Where am I? Is this possibly caused by something that we like did in pre-stream? And I just didn't notice? Oh, Zolo, thanks for the prime. Missed it. Like, this shouldn't fucking be happening. Git stash. Zig build. And then can we just add that same assertion back? We need that same assertion. So that was in on mouse move. We were checking. This is on mouse move. We were basically saying stood debug assert. Nope. We said if self, was it metadata way tags len is not equal to 201 unreachable, right? Ooh, Maybe it's... It's weird that this is still working at all. I guess the runtime traps here are that's pretty funny. I guess they're like they don't like disable the module completely. It's just like in that one handler we throw an exception, then we're like still good to go. So we want to log debug num way tags was this, and let's just double check that it is still 201. It might not be. So I just want to see that we see this at least. Okay, yeah. Sick. Okay, wait. This is actually really good. So we are actually still seeing this corruption even without any other changes. So that actually like really gains us confidence in some way. I mean, it's not good, right? It's definitely not good. So where is this? Is it? What the fuck? Okay, so now we can just start bisecting. We can see if we fucking okay, so let's git add-u git commit-m. We'll call this like debugging of corrupted way tags. Right? And then we can git checkout a bit back and get our git cherry pick whip. Build again. It's possible that we could have fucked this up in our like rejigging to support the offline version of the app. Yeah, okay. So this is actually just running just fine, which is actually, that's really useful. That's really helpful. So we know that this commit caused the problem. And now we just have to understand why. So it turns out that doing small tasks off stream causes big problems on stream. Who would have guessed? So we added this dinit call. No, we're not calling dinit on the WASM side. So no biggie there. We did start stashing an allocator. Okay, and here we added some error defers here where we dinit stuff. But I don't think that should matter, but we can take a look at that. We changed some guys to take in metadata copies instead of pointers to the metadata, which I don't think should matter, but could. This stuff is all not related. Oh my fucking god. Oh, fuck. Guys, we're so stupid. This is so stupid. Fuck. Okay. I mean, at least it's like a simple fix. So, we just accidentally started storing something on the stack. And then we pass in a pointer to that thing on the stack, and then you store that pointer forever. Of course that's gonna fucking fail. God damn it. It's okay, it's easy to fix. So that also explains why it's only happening on the WASM side, is because we are only referencing invalid data on the WASM side. Okay, look. Yes, we. Because I meant the royal we, okay? Not we as in you guys. That's so frustrating. Very slight mistake, very major problem. Oopsies. Whoever asked if I like Zig, this is maybe some of the downsides. Although I probably could have made this mistake in Rust as well, just as easily, because like you need the like not working with global data in this scenario is like kind of annoying. So it's possible we would have just hit the same thing with, and we just would have used unsafe code. Okay. Yeah, okay. This should be fine. So this is still using like a heap allocated thing, but the heap allocated, we're not pointing to like a thing that's on this. Yeah, I think we're good. We're good. Should be good. Uh, so we'll say git commit dash m fix corruption, and then we'll build and retest. God, what a fucking waste of time. Little aside there. Oh, still broken? What is he unreachably on? Oh, I just went out of the canvas again. This is the expected crash, not the unexpected crash. Yeah, that's much better. Okay, git stash pop. Merge tool. What's he complaining about? This is fine. We'll get rid of this. Okay, large aside, very annoying. Yeah, it's fine. Now we just have to undo some of the stuff we commented out. Fuck off. Okay. It's fixable, it's fixable. So what did we do? What did we do? So maybe we'll kind of say that we did some sort of, before now, we did, oops, invalid, crashy. There we go. And we have to fix all the stuff we commented out. So this comes back. This comes back. Watched a YouTube video yesterday. Didn't realize you stream. Glad I found you. Hey, I'm glad you're here. Number go up when you're here, and number go up make happy. Which is a really insulting thing to say to you, as being like, I think you are a number. That's rude as fuck. So I take it back. We'll pretend I didn't say it. And if we just all agree that I wasn't an asshole, then I'm not an asshole, right? That's how it works. This comes back. I'm enjoying this very much, by the way. Yeah, I mean, I think it's like it's a fun little thing. It just means that I have to change the YouTube title that I had in my head. Maybe if we don't get to because it kind of like derails a little bit because I was hoping to get to like a finished A* implementation today, and now I just think that because of that we might not make it, which is a little annoying. But it is what it is, you know. This is what we get, and the joys of working on side projects and not for a company is that you get to do these asides, and it shouldn't actually be a problem. You know, this was supposed to say potential ways. It's not the end of the world. Way buckets. We forgot to uncomment that. Then hopefully we're back to working. Refresh. Okay. Okay. I think we're back. I think we're so back, baby. And can we build in release mode and run on the full version of the site? Boys, we are so back. We're so back. Okay, give him a sec. Let's go back to full Vancouver. Full Vancouver, baby. What the fuck? Wrong version of the site. That would do it. We need 123.534, not 114. Of course. Of course. Maybe I should name these things so that I can tell the difference. Right? We could call them full Vancouver and very small subslice of Vancouver for testing only. But instead, what if we just memorized a few coordinates? He's thinking. He's working hard. But then we'll get there. Okay. This takes about 5 seconds now, which is a bit of pain. Oh my god. Oh, this is asserting now correctly because we have an assertion just hard coded in here that it's 201, which is just not true anymore. That is correct. We have to wait 5 seconds for it to finish doing the conversions. But we're finally there. And this map is much more the right shape now, which is a big win. Big win. We could even maybe look up Vancouver. I'm gonna do it over here off screen so it doesn't like leak my address, my location. But I think it's upside down. It's definitely upside down. So when we did the latitude longitude conversion, we have to subtract from max lat instead of min lat, or just invert y. I did think it looked kind of funny. I did think it looked funny. Let me see. So index zig app.zig. So is it true that latitude, yeah, maximum latitude should always be top left, even if we're on the southern hemisphere? Not that we ever will be on the southern hemisphere, but I just want it to be like kind of like correct, you know? And so this is still fine, I think. And then if we're trying to go latitude, we want 0 to be top left. So if we're trying to go lat step times lat it's mat lat minus lat. So then if latitude is top left, this becomes 0. And if it's 0, yeah, the bigger latitude here becomes closer to 0. Smaller latitude becomes bigger number. Yeah. So we just have to invert this. Fuck. Mat lat, max lat. One Mississippi. Oh. Wait, that went way faster. One Mississippi. Why is it so fast now? I wonder if the memory corruption was resulting us just... Oh! Yeah, I wonder if the memory corruption was resulting us in like iterating just like a billion streets that didn't exist. Oh, no DevTools, you think? 1 Mississippi, 2 Mississippi, 3 Mississippi. Wait, why? Oh, oops, I accidentally ran the fucking thing again. Oh, why does the DevTools make it so slow? Is it because I'm trying to pause on exceptions? 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi. I don't understand why it's so different. But whatever, we'll take it. We'll take it. Okay. So all of that to get to this. Okay. So let's try to basically figure out which node we're attached to. And I think I've decided, well, let me look. Let's see. Do I care about this? Can we just use the first node? Can we just like use the first node in the way? The ways can be kind of long. The ways can be kind of long. So we will do this. We will do this. Okay, but I think it should be pretty easy actually to find the node that we're selecting because we're already finding the way. And to find the way, we already have to figure out which line segment we're close to. So all we should have to do here is like when we finish this calculation, we should just be able to say min way segment. So we can say that like a way is made up of steps between multiple nodes. We can just write down which one it was. Now I'm curious if there's a Rust crate to read these maps already. That's not the fun part. That's not the fun part. The fun part is we do it all ourselves, like fucking idiots. Min way segment is undefined. And here, while we walk, we should just be able to say min way segment is equal self segment IDX. By the way, guys, okay, so I did this refactoring off stream, and I don't know if I've told you guys recently like how much I'm fucking into iterators right now instead of loops. But this is actually like really fucking sick, so I think I'll, and we're already off schedule, so who fucking cares? We'll just waste time talking about stuff. But okay, so what the fuck? Why isn't this? Why isn't it working? I was trying to show something cool. Oh, that's annoying. Why is it broken? I was going to show the fact that using an iterator makes implementing this visualization really easy, but now the visualization just isn't fucking running. Why? Hold on, we're going on a tangent. Debug is set to self-debug. That's so sad. It's so sad. He doesn't like that because I have to write B for Boolean, probably. We're suffering from not invented here syndrome. I mean, I will say that I'm not against not invented here syndrome. I think that in production, maybe not, right? But I think that remaking stuff that you're not supposed to make really makes you, like, gives you intuition that you wouldn't have otherwise. And I think that's very important. Yeah, I think that's useful information. You know? Sometimes inventing here is the most fun and educational. That as well. That as well. What am I looking for? Index zig, we call, nope. Index zig, we call format. We don't, here. Buff print. Oh my god, format. Here we go. This is what I'm looking for. I'm just looking for the fucking format strings. Which one of these things is a Boolean? Oh my god. Integer value, no specifier needed for bool? No way. Just empty? You're serious? It's just this? Wow. Crazy. I didn't know that. Have I just never printed a bool before? Yeah, so debug is true. Is my renderer fucking broken? It should be rendering points here. Maybe I didn't set the point size? No, I am. Debug dist. This is actually quite confusing. Because we showed this earlier in the stream today, and it was working just fine. Dist is a number. Am I fucking high? Give him a sec, he's thinking. Optimize was really safe. What was I supposed to do? Okay. Like, what the fuck is going? I mean, yeah, we are seeing a bunch of distances. They're just not getting rendered anymore? What the fuck is going on? Did the dist change with the coordinate change? Oh, good thought. Yeah. So the scaling of this is just totally fucked now. The scaling of this is just totally fucked. So if we are doing e to the negative distance, and we want the things to look bigger now. I took your advice, by the way. Whoever was telling me to do e to the negative distance the other day, I got it, or e to the power of negative dist. So we want this thing to get closer to 0. So we want to, the scaling of this thing is just fucking broken. Does it include height data? Not yet. We will probably look at that eventually. But there we go. Okay, so this scaling is just fucked up now. Okay, sorry. All of this was just because I wanted to show that using an iterator here makes attaching debug data like this way easier. But There we go. Okay. So all I was trying to show was we have this thing where like basically the closer I am to a road, I like render those points as bigger or smaller. Right? And all I was trying to say was that I'm super into iterators now, because now all of a sudden, in order to like this calculation, at each step of the calculation, we, instead of running like a double for loop that like computes the distance to every single way or every single road, we can run this like step function who returns as part of his like intermediate output. He says like, okay, like just so you know, this is like the stuff I looked at in this step. And then all of a sudden, like binding that data to the renderer is like super fucking easy. We don't have to like pass a renderer into our like calculate algorithm. We can then like do all this stuff externally. And all I was trying to say was I'm fucking into that idea recently. And so that's why when I was going in here to add in the segment of the way, it's like in this like weird iterator class, but the weird iterator class is like super nice. And that's all I was trying to say. And we got distracted because it was fucking broken. What are iterators like in Zig? I'm a fan of Rust iterators, but never like C++ iterators. Well, let's just say I don't really care about like iterator API necessarily. I'm just saying like some class that you can call step, right? And so here our step is returning a nullable. So it's something that might be null, that might be something. Yeah, the C++ iterators are like kind of fucking annoying. But I'm just saying like a function that returns a thing is basically all I was trying to say. Okay. What were we doing again? We were trying to see which way index we're looking at. So now we've stored which segment ID we're looking at. And so now when we look at the min way value, we should be able to extract which node we're looking at. So we should be able to say here, let's just say that we are going to render unconditionally the coordinates of that node. So we're going to look at self ways get, okay, we're going to say const way is equal to this. We are going to say that the node is the way at calc min way segment. And here we have to ensure that if assert if calc min way segment is greater than way len points, node ID is len, we have a fucking problem. Invalid segment, and then unreachable. Then here we can say the node is the node ID at that segment, and the node is the points get node ID. Okay, then we can render. I guess we can just render chords. Render selected way, render chords, render points. I guess we just have point ID to render. So this is just we don't even need the node. We can just say bound renderer render points at node ID. And we need a point size. So size we're going to say like 10. Cool. Also, C++ 20 ranges and views and stuff made it a lot better. I'd believe that, although they're very late. Okay, there we go. So we're seeing a point drawn on which node index. It's not perfect, right? But it's at least like semi close by to where we're pointing. So I'll live with it. Good enough. We could do like some sort of like distance check for like if we're between two, which one is closer. But I don't want to do that right now, because all of this was just so that we could have like a starting point of our A* walk. Okay, build walkable node graph. So we need to be able to basically go from like if we're at, oopsies, what the fuck did I just do? If we're at this node here, right, we need to be able to say like which nodes are close by to us. Which we don't really have right now. We have like the concept of ways, which are links of nodes, but we don't have the concept of like given a node, how do I know who is attached to me? Which should be pretty easy to generate, right? We already ripped the nodes we will like rip through the ways one time on initialization, and so we should be able to like just generate as part of that a like node adjacency map. So what is that going to look like? I don't really know yet. So given given one node ID, you're going to want a variable list of all node IDs that are attached to it. Okay. So how do we want to store that? I guess you're forced to have some sort of variable behavior, but we could just you could stick it all in one big array and then store indexes into that array for like which node you're talking about. Right? So you could just have like uh nodes. Okay. So this is going to be like big ass array, right? Big ass array. And then here we're going to have like segment starts or something. And this is going to be like given a map of node ID to index into nodes above. So the idea here is that the nodes array will look like, 0, 1, 2, 3. And these are, or maybe we'll say for node 0, we have 1, 2, and 3. And then for node 2, we're going to have 1, 3, and 0, right? And so this is just going to look like a bunch of like fucking integers or whatever. And we'll just say in segment starts, we'll say that for node 0, we're looking at the first 3. And then for node 1, we start at value 3. And then for node 2, we're going to start at value 6, right? So when we are trying to do our lookup, we're basically going to look at the values in nodes as our neighbors for the values between my node ID and the next one. So this is like, we're going to have like start is going to be segment starts ID, and then end is going to be segment starts ID plus 1, if ID or like the end of the array, and then we'll like say that our neighbors is like nodes from start to end. That's kind of the idea here. And I think I'm okay with that, right? Because we do want all this stuff to be close to each other in memory, because we are going to be like ripping individual segments at once. Maybe it's like not like maybe this is like an over optimization. Maybe just doing like a hash map lookup would be fine. But I like to avoid hash maps when I can, because I've had experiences where like I know hash maps are fucking fast, but what's a lot faster than hash maps is doing no math at all, right? And so I think that this storage format makes it so that all you have to do is like pointer offsets. So there may be some benefit in like memory locality, but in reality, like what I'm really looking for is like just none of the overhead of having to hash my node IDs over and over again, and like figure out which buckets are in and stuff like that. So I think that this is fine, because we don't have to worry about like what's nice about our scenario is we don't have to worry about like insertion expense, right? Because we're doing like all of the like initial lookup and stuff like one time. So I think this is fine. I think this is fine. Now we're gonna maybe say function get. Let's just like write this now so that I don't forget. So this is gonna give me like neighbors for node. We are gonna get a bunch more neighbors. And so this is gonna say self this if ID. This needs to be id.value because it's a strong type, because I keep fucking up the indexing. If id value plus 1 is equal to self segment starts len, we say, oh, that's actually fine. Oh no, it's not. So if this is this, then end is going to be nodes len. Yes. Else it's going to be this. const end is equal to this, and then we return self nodes start to end. Sorry, I've been missing chat messages. Skimming. Just talking about Rust stuff. Okay, yeah. Nothing I have to respond to. You're not talking to me. So just checking. Just checking. Okay, so this needs the oops, this goes here, and then this goes here. Boom. Okay. This needs node.value, not ID, and then node.value here, and then self nodes len and node value plus 1 self segment starts. Okay. Okay. So now we have to figure out how to like build this thing. So I think that we're gonna take in on init. We're gonna take in like a hash map. Stood auto hash map of what? Usize to sorry, I'm thinking. Because I want to build this thing with a hash map, and then at the end, serialize the hash map into this storage format. So I want to see something like, can we, I want to see like what APIs we have. Zig standard lib. Auto hash map. So this returns me a hash map. And I'm trying to decide like, probably I want to iterate over the hash map. So we could maybe like take in an iterator, rip the iterator, look at the key, use the key to index. We need to iterate in order. So maybe we just take in the hash map. So we're gonna take in like neighbors. Gonna be a stood auto hash map of usize node ID. Yeah, he's gonna go from node ID to this. Is this how you would store this in Zig? No. Maybe this goes to an array list. I feel like there's a good chance that there's like a type in here, that there's like a multi-map type already. Do I want to use an array hash map and then keys for insertion order? Let me think about what do I even want here. I don't think I need a hash map at all. Now that I'm thinking about it, I think I want like a double nested array even. We could do this. Yeah. That makes most sense to me, actually. So for each index into this thing, we have a bunch of neighbors. That feels nice. Good night, everybody. Good night. Hope we see you again someday. Yeah, this feels like what I want. Then here we basically say var output nodes is going to be a array list of node ID. Probably initialize some allocator. We're going to deinit that thing later. And then for I for 0. I think we just do this. We also want the segment starts here. Like this. And we're going to say for neighbors. Okay. For neighbors, then we have like neighbors. So like we want like node neighbors, I guess. This becomes node neighbors, and we have neighbors. We say output nodes push something. I don't know what yet. We want to append slice neighbors. Yes. Okay. Then the segment starts. Append output nodes len. Yes, 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 yes. It's all coming together. It's all coming together. So here we say, hey, this index into the array, grab these. Here we say, now we like stick them in there. This is shadowing a declaration. Oh, fine. We'll call it get neighbors. Then at the end here, I think we're just good to go. So we just say return nodes is equal to output nodes to owned slice, and segment starts is equal to segment starts to owned slice. Okay. Okay, so now all we have to do is we have to build this node neighbors thing, which is done somewhere. Parse index buffer. So here we rip the index buffer one time, and here we're just going to say node neighbors is going to be a stood array list of node IDs. At the end of this, we're going to walk all of these things. And for each of those, we're going to say item D in it. Okay. So now for each okay, I guess maybe this doesn't have to be an array list. Surely we know how many points there are. We must have that information somewhere. We do. So here we'll say the number of points is just the self points len over 2. Because these points are stashed as like alternating longitude latitude. So the number of points is, half those. Which means that here now we can say that we know this is going to be a slice at the beginning. And then it maybe makes more sense for this to be unmanaged, because then we can kind of say we can do something like allocate some of these guys, and we want to make however many points there are of them, right? Then we want to memset all of these guys to like the default value. Oh, so I guess we can do that memset either way. That should work like this as well. So you can do like memset. No, we can't. Can we? When we init this thing, is there any like specific to this version? No, his items is empty, his capacity is empty, his allocator is empty. So if we did init with capacity, then it would be a fucking problem, because all of them would have the same items pointer. But since all of the items pointers start as like null, essentially, not really called null, but like empty slice, I think it's legal for us to do this. I think. Although it is stupid for us to store that many. So fuck it, we'll use the unmanaged ones. The unmanaged one is a little nicer anyways, in our case. So I think we just do this. Maybe. Then we don't have an items thing here. And then here we do alloc free node neighbors. That seems reasonable to me. Then here, on each iteration, we say node neighbors at way at the given node ID, we need to append his neighbors, which means something. And whoever two-step earlier when he said that I should use a hash set was right. He was right. This should be a hash set. But we'll get there. We'll get there. Because first I want to figure out how to resolve his neighbors. So his neighbors are just the node before and the node after. So we want to kind of throw an I in here. And we'll say if I is less than greater than 0, we append, append node, oh god, way node IDs I minus 1. Yup. And if I is less than way node IDs len minus 1, then we append I plus 1. There we go. Woo! It's tricky. Tricky, tricky, tricky. But we got there. We got there. So, oops, that's his minus again. That should say plus. Okay, this should be a hash set because right now we're gonna have duplicate connections, almost certainly. So this should be auto hash map going from node ID to void. Then we set this to auto hash map. Does this have any allocated pointers on it? Oh shoot, got an ad, but you did -1 instead of +1. Yeah, I caught it, thanks. Smile. Poor guy. He can't hear me. He's deaf right now. So this takes in nothing. Yeah, no like specific stuff here, which is great. Which means that it's safe for us to do this memset of auto hash map node ID void init with allocator. Okay. And then at the end here, we need to like take this thing and we need to create the actual thing that we wanted to return, right? Which was the fuck. Dude, my poor brain, sometimes it's like so hard to just keep track of what the fuck is going on. There's like too much happening. Node adjacency map. So this guy needs to get returned here. And then at the end of all this, we need to say that the node adjacency map is equal to node adjacency map initialized with an allocator and our node neighbors. And then we return this as part of this. And that's probably a point where we can hit build now. So 304, he doesn't like that D in it is not a pointer. He's like mad because it's constant by default. There's nothing append here anymore, so it's actually supposed to be right, when we switched it to a hash map or a hash set, which is kind of like a hash map in a lot of ways, this is no longer append, but it's like put like this. This is put like this. Okay. Here he's mad because we got the type wrong. Here now, this is supposed to be a auto hash map. You could still use the unmanaged version. Yeah. Do I want to? Yeah, it's probably better not to just like waste memory for no fucking reason, huh? You're right. You're right. Fine. So this is unmanaged, and then here I think there's no init for unmanaged ones, so we just kind of do this and unmanaged here, and then here we probably have to put with our allocator, and then here we have to de-init with our allocator, and then it's probably fine. 328, he's mad about expected a slice of array hash map unmanaged. Oh, I typed array auto. Oops. Whoopsies. Wrong word. Uh, expected something found out of memory. Oh, because here, this has to be failable. Of course it does. Then down here, when we initialize this thing, he has to be tried. Uh-huh. Expected node IDs found this thing, right? So this is at 53. So here, instead of doing this append slice, we actually have to iterate the keys. So here we look at neighbors keys, and then we could do this if this was auto array hash map unmanaged. What a type. What a type. I don't really know what type of like runtime cost I'm taking for that, but fuck it. The fact that we compile is crazy. I wonder if we run. 3 Mississippi. Okay. Okay. We might be in a like reasonably okay state, to be honest. So now we just need to stash that thing. So we should be able to say here that the what do we call the thing? No, the adjacency map is a node adjacency map. And now let's fucking like visualize some adjacent nodes, because we believe that this is ready to go. Who fucking knows if it is? But it might be. You never know. Okay, so visualize adjacent nodes. So maybe what we'll do is on mouse move. Here, let's just look up. So we earlier found which node we're looking at, right? And so we should just say, neighbors. It should be the node adjacency map get neighbors for this node ID. And we should be able to just say, render the neighbors. Fuck. So a bunch of code that wasn't compiling now is compiling, and it doesn't work because it's fucked, of course. 262. And it's, what? Neighbors, missing struct adjacency map at 168, right? So 168. Here we need, adjacency map is the third element that comes out of here. Is there no dinit on this thing, which is kind of funny? We should probably fix that. Certainly it needs one. But for now, because we are in prototype mode, we will just let it leakies. Expected this, found that, right? So at 267, I accidentally put this thing in. I said I have a slice to pass this thing, and I already had a slice, but then I put in a new slice. Double slicing, not cool. Segments start, not available, so at 65, it's segment starts probably. And then 2, 3, 4. Oh, hell yeah, baby. Oh, wait, it's actually fucking working. Oh, hell yeah. Okay, let's change the color. We'll change the color of the ones that we are, that are not us. So maybe we'll render our neighbors in blue. We only have like control of the red of red right now because we were too lazy to make other ones. So fuck it. So we'll say that the we'll render our selected point as white. So I think if we do this order, then it will be fine. No? Why is he being rendered in blue? Pretty much first time. Yeah, that actually went like shockingly well, to be honest. Like very shockingly well. Yeah, this is supposed to be white now. I don't understand why it's not. Because here when we render the node ID, we set the color to 1.0 first. So I don't understand. Oh, because on render points I just hard code it to whatever the fuck I feel like a dumbass. Okay, that makes sense. So up here I should set it to 0 probably. Then spends 20 minutes on the color. Classic, classic. Okay, yeah, that's pretty sick. Okay, so here we're seeing that like the node that we are selecting as our start position is the white one, and then he's showing his neighbors in blue. And that's very surprisingly working first time. Which is pretty crazy. Pretty fucking crazy. Oh, that's actually like a lot of these visualizations are like kind of fun to look at. I'm not gonna lie. Like this walking this road feels like weirdly satisfying. Oh, chat, by the way, I think that we fixed the vertical mouse tracking. No, I lied. Just kidding. I thought we did. Because it probably needs to be multiplied by aspect. So I bet you if the window is square, vertical mouse tracking works. We can make it work. Maybe it work. Oh, so close. So not square. Not square, so there's a bug. There might be a bug still in here. But okay. Pretty good progress for today. I wish that we had got to like the actual A star implementation. Because now I feel like there's a good chance that tomorrow's stream it might end up being like too short. But I'm sure that we'll figure out something to do instead. Because yeah, it felt like it would have been a natural conclusion to this to get the A star working. But fuck it, we'll do it tomorrow. So, what did we do today? Today we fixed the unwrapping of this map. So this is now at least somewhat reasonable like X and Y. So before we were working in like units of coordinates, now we're working in units of meters, probably. I don't know. Some unwrapped coordinate system. We fixed some crashes related to some poor memory management on my side from the happy hour today, which oopsies, but fun investigation either way. We added this like node adjacency map and then added some tracking of like which node we pick a node somewhat close by and we can render which ones are next to us now. So pretty fucking good. Pretty fucking good. Yeah, I guess that's kind of it. But I guess we also removed all of the buildings and stuff from here. So we only have roads on screen now, which is another big win for us because it means that we don't have to waste a bunch of time doing stuff that isn't really related. So, yeah, okay. I think we're gonna call it there for today. Tomorrow we'll be back and we'll actually do the path planning, which was the plan for today, but whatever, we'll get there tomorrow. We'll get there tomorrow. If you like what you saw, we stream most days at around 2 o'clock Pacific time for the main course. Then we do like happy hour from 12:30 to 2. The difference is that like we're focused on like what I call prototype mode for the main course, where it's like we're trying to get some feature out and we're just taking like whatever shortcuts we have to get to like kind of prototype that thing, which means that we have a bunch of things left behind that are kind of shit, right? For example, here we still have GPS coords leaking around over it. We're calling them GPS coords. They're wrong. These things aren't stored in latitude and longitude. These are stored in meters. So happy hour is kind of about like going back and fixing things that maybe isn't so exciting to have on YouTube videos, but is still like important work. Or maybe we'll be doing like small things that aren't super important or like aren't like worth their own YouTube video. So today in happy hour we were looking at compiling this same application as a desktop application so we could run Valorant on it, stuff like that. So that's at like 12:30 to 2 Pacific time. Or if you're watching like main YouTube VODs only, those are like 2 to 4. If you're on Twitch, there's a YouTube link in the Twitch description where you can see playlists of all the things we're working on. So we're working on this map right now, but we've worked on an operating system. We worked on this like 3D graphics engine for our stream intro screen, like a terminal emulator, a QR code decoder. There's lots of stuff in there if you want to go check it out. There's a GitHub link in the Twitch description as well. If you want to see like the code for this, it will end up in this FMAP repo. What else? If you want to throw money at me for whatever reason, there's Twitch subs and Patreon subs linked again in the descriptions. And what else? Like, subscribe, Twitch Prime, all the typical YouTuber, streamer bullshit. And I think that's all we have to plug. YouTube, goodbye, and Twitch, let's find someone to raid.